Welcome to module HU001 of Oricon's Upskill Modular Training Program devoted to Revit and BIM. This module is titled Pipe Types and Pipe Systems and is brought to you on behalf of Oricon by A2K Technologies. We will be using the purchased materials supplied by Oricon and A2K Technologies. Classroom notes and handouts are available for note-taking through the exemplar portal. Throughout this lecture, we will be covering the following topics: introduction, pipe settings, pipe types, pipe systems, and a summary. Introduction. Revit offers tools for designing pipes and pipe systems. It is crucial to understand how to set up pipe types and pipe systems properly. This will allow the design tools to work reliable according to standards and other requirements. This module will be introducing the setup and properties for different pipe types and pipe systems. To follow this lecture, open the file master MEP hydraulic HU001 and make sure that the reference file arc link model is located in the same directory as the main file. Open up a 3D view. Pipe settings. Open the Mechanical Settings dialog in the Manage tab under MEP Settings. This dialog is the main driver for the definition of default mechanical settings, including pipe settings. Main setting hidden line is controlling how MEP system elements are displayed, which are hidden by other MEP elements. Currently, the tick box to draw MEP hidden lines is ticked. Select OK. Go into your floor plan 01 training system under plumbing. Start the pipe command in your system tab and draw a pipe with a diameter of 267 across the blue pipe up here. Escape, escape. Zoom into this area a bit closer and find that the hidden pipe is showing up in a hidden line style. Go back to your Manage tab, MEP Settings, Mechanical Settings, untick the box for Draw MEP Hidden Lines, hit OK, and see the changes. Delete the newly created pipe. Zoom out a bit and go back into the Mechanical Settings, Pipe Settings. Those main pipe setting options provide control over annotations and symbolic appearances. Angles provides the option to allow any angle for pipe routing or to only use specific angles. With Use Any Angle activated, hit OK, go to your Systems tab, draw a pipe, select diameter 15 mm for example, and draw a pipe run. Just notice that basically any angle you put in is allowed by the pipe run. Hit Escape, escape, go back to your Manage tab, Mechanical Settings, tick the box for Use Specific Angles and untick all those provided angles other than 90 degree. Draw another pipe run and find that whichever angle you put in, Revit always creates a 90 degree angle. As per our new definition in the mechanical settings, only 90 degree angles are allowed. In the conversion settings, the user can define default values for pipe types and their height offsets for all available system classifications. Those default values will come into play when layouts are generated via the Generate Layout tool, which will be shown later on. Segments and sizes. A pipe segment consists of 4 separate main definitions. When selecting Create New Pipe Segment, we've got the schedule type. This can be a random name or a norm that the segment is referring to. We've got the material. We can pick any material from the material library. The segments have defined properties like the roughness parameter, which is an important calculation parameter, and we also have a size catalog with the definition of available sizes for this particular segment type. The size catalog itself offers several different sizes like nominal size, inner diameter, outer diameter, whether we want to use those sizes in drop-down menus or whether we want to use particular sizes for calculations. Please note that any fittings connected to pipes will always be created according to the nominal diameter. Calculations will also be conducted using the nominal diameter. As an exercise, we will create a custom segment type. We will create new a material and schedule type. Select the material, steel carbon, and type a name for the schedule type in. We'll call it training. Make sure that we duplicate the size catalog from an existing one, which is PVC. Hit OK. We will use this segment later on to define a pipe type. Fluids dialog. We can create and define fluids with viscosity and density parameters according to specific temperatures. The listed fluids will be selected to define pipe systems properties in a later step. Slopes. Slope values can be predefined and then selected while drawing a pipe via a drop-down menu or when using the slope editor. At the moment we do have 6 different slope values we can pick from. Hit OK, go to your 3D view, select the last pipe segment of the sanitary system and select the slope command. The pull-down menu for the slope value contains the slopes defined in the mechanical settings. Select 1 to 50, select Finish, ignore the warning, and select the pipe again. Keep in mind that this pull-down menu for the slope values is only for pre-selection. Any slope can be defined manually regardless of the presets in this menu. Click on the slope value and type in 25, enter, and see that the slope value has changed manually. Hit Escape, Escape, go back to your Manage tab, MEP Settings, Mechanical Settings. The last menu, Calculation, provides details on the calculation methods used for pressure drop and flow. The pressure drop within a pipe system by default is calculated via Darcy-Weisbach equation. Third-party products may add additional options to this list. Volumetric flow by default is calculated using fixture units according to the listed norm. Also, third-party products may add additional functionality and calculation methods. Pipe types. A pipe type is a system family and consists of a name, ID data, and its main definitions in the routing preferences. In this dialog, the pipe segment and default fitting families are assigned to the pipe type. This way, the user can create a pipe type, for example called steel flanged, and only assign matching flanged fitting families as elbows, tees, etc. If no pipe fitting is assigned, for example as a cap, Error messages will pop up during auto-routing tasks or once specific commands like cap open ends is used. As an exercise, we're going to create a new custom pipe type. Go to your project browser, scroll down a bit till you find the entry pipes, expand pipe types, and right-click onto the standard pipe type, duplicate it, and rename the duplicate to CS butt welded. Double-click on this newly created pipe type to open the Type Properties dialog and edit the routing preferences. In this new dialog, we assign our previously created pipe segment called Steel Carbon Training and select None for all the different fitting types. As next step, we need to find a butt-welded elbow fitting. At the moment, we don't have any loaded into the project, so that won't show up in here. We have to load a family. The family we are after can be found in the dataset folder and is called elbow butt-welded CS. Hit open and assign this family as the elbow. As the minimum size, we leave it as all. We do have the option to add additional rows to assign different elbow fitting families and types to minimum and maximum sizes of the pipe. Also keep in mind that the fitting has to support the nominal sizes from the pipe segment via a lookup table. This exercise won't cover any details about lookup tables and how to set up fitting families properly. Finish the pipe type creation by hitting OK and OK, and rotate the view by right-clicking on the view cube to the southeast isometric view. Select the last pipe segment of the sewer pipe and change the pipe type to the newly created CS butt-welded pipe type. Go to your Manage tab, MEP settings, mechanical settings. Make sure that under the angles option, you select use any angle. Hit OK. This should allow us to create pipe runs in any angle. Select the pipe segment again, zoom in a bit, right-click onto the end connector here, and draw a pipe in a 90-degree angle, which works fine. Also, try to create a segment in an angle not equal to 90 degrees, and find that this is not possible. Even though that we have defined in the mechanical settings that any angle should be possible to create, we get an error message that no auto-route solution was found. This is due to the fact that the fitting family we have assigned as an elbow in the pipe type does not support angles other than 90 degrees. Any angles which are required as part of the pipe type have to be available in the elbow fitting family as well. Cancel this error message, hit escape, select the elbow to double check that the family used is the one assigned in the routing preferences. It should be elbow, butt-welded, CS and the standard type. Pipe systems. Pipe systems combine equipment and pipe runs into logical systems. They are used to set up the parameters necessary to calculate flow values and sizing. One pipe system can consist of several equipment types and instances, as well as different pipe types. To clarify this, change the visual style from hidden line to realistic. Hover over one of the pipes down here, hit Tab 5 times, select the pipe system, and find that within this pipe system, different pipe types are used, like this one here. It's a plastic pipe. Further down here, it's a carbon steel pipe. At the same time, we've got several different equipment instances as part of this pipe system. Navigate to Pipe Systems in your project browser and create a new piping system type by duplicating the sanitary one. Rename the new one to Sewer Training. Open the type properties by double-clicking and set the graphic overrides to magenta. Okay. Additionally, there is an option to set a material as graphical override for all elements within a defined pipe system. Other options in here are what sort of calculations shall be conducted within this system, ID data parameters, as well as rise and drop symbols, which will be visible in plan views. Note that there are no options to assign fluid properties for this particular system classification, sanitary. Apply the changes by hitting OK. Fluid properties. Open the pipe system type properties from the domestic cold water system. Fluids and their defined temperatures can be assigned to piping systems in the type properties. The viscosity and density parameters populate automatically when the fluid type and temperature is selected. When I change the fluid type, viscosity and density will change. This happens according to the settings in the mechanical settings dialog mentioned earlier. Also note that only system classifications where fluid parameters are relevant for calculation purposes offer the option to set a fluid parameter. For example, domestic cold water systems or domestic hot water systems. Select the sewer training system type. To conclude this, we have just created a new piping system type called sewer training. And in the next step, we will be creating a new piping system, very similar to the existing sanitary one. Hit OK. In your project browser, scroll up and open Floor Plan 01 Training System. Zoom all and create a couple of toilets in the next room. One here, one there. Escape, escape. Select the sink, including vanity, and copy it into the next room over here. And ignore the warning message. Escape, escape. Go back to your 3D view. Zoom out. Rotate a bit. Select all the 3 equipment elements and use the command piping to create a new piping system. In this dialog, select sewer training and leave the system name as it is. Hit OK. While the system is still selected, choose the command generate layout to create pipe runs automatically. In the options bar, we select network as solution type and pick solution number 5 or a solution that looks similar to the one displayed here. Go to the settings dialog and type in an offset of -400 millimeters for the main pipe run as well as for the branch. Remember, these settings were preset in the mechanical settings dialog as mentioned earlier in this module. Hit OK. Select the slope value of 1/80 and finish the layout. Summary. The proper definition of pipes is generally completed considering 3 main steps or menus. First of all, the pipe settings in the mechanical settings dialog to define project-specific rules like pipe segments containing material and size information. These settings should be predefined as a company standard via the default template. However, the use of specific manufacturers for piping might require manual adjustments from project to project. The second step is pipe types need to be created by assigning desired fittings for various routing solutions. Special care has to be taken that the designated fitting families are working properly and cover all necessary angles and sizes. Last but not least, pipe systems are defined to differ between the system scenarios. They are the main driver for visual appearance of components and how the calculations are conducted. The properties also rely on the data from the pipe settings dialog. Details about the calculation methods will be covered in module HU002. And this concludes module HU001, Pipe Types and Pipe Systems.